The escape speed can be derived using the principle of conservation of energy. By the principle of conservation of energy, total energy of a body on the Earth's surface equals its gravitational potential energy at infinity. At infinity, R equals infinity. Gravitational potential energy equals negative G MEM over R equals 0. Hence, half mv squared of negative G MEM over R equals 0, which implies V equals square root of 2 times G ME over R, where V is the escape speed. Substituting G equals 6.67 times 10 to the power negative 11 Newton meter square per kilogram square, ME equals 6.02 times 10 to the power 24 kilograms, and radius of the Earth R equals 6.4 times 10 to the power 6 meters. We get V equals square root of 2 times 6.67 times 10 to the power negative 11 times 6.02 times 10 to the power 24 over 6.4 times 10 to the power 6, which equals 11.2 times 10 to the power 3 meter per second.
Okay, now we look at here. If we wish to throw a stone from the surface of the Earth, that means that we need to throw with a speed of 11.2 times 10 to the power 3 ms negative 1. So this means that the speed is quite fast. So from here, if m compared to the car, yeah, so at the limit of car on the highway is 110 kilometer per hour, right? 110 kilometer per hour, just around 33 ms negative 1. So now we need to throw 11.2 thousand ms negative 1. That means that normally this is just a concept, okay, to launch or to throw something from the surface of the Earth that allow the object completely free from the gravitational pull. First, why we must use a satellite, use a rocket to bring the astronaut to the space? First, the first reason, we cannot launch with the 11.2 times 10 to the power 3. That means that if we wish to launch the astronaut must be moved, okay, maybe downward into the Earth first, so that they need a very long distance to accelerate. Once it reached to the surface, the speed reached on the surface of the Earth must be 11.2 times 10 to the power 3 ms negative 1. If less than that speed, it will fall down. More than that speed, no problem. Minimum speed is 11.2 times 10 to the power 3. First. Second reason we cannot use this method is because if we launch with such speed, human heart not only will stop, but maybe broken. Okay, so this means that, okay, the heart will break and the people or the human in the spacecraft with this speed, so everybody will die immediately. Okay.
Summary. The total energy E of a satellite orbiting the Earth is given by E equals negative G MEM over 2R. Escape speed of the Earth is defined as the minimum speed with which an object should be projected so that it escapes completely the gravitational pull of the Earth. Escape speed from the Earth's surface, V, equals square root of GME over R.
Ladies and gentlemen, as a result, first, the speed of the satellite in circular orbit at a distance r from the center of the Earth is v equal to square root of 2 GME over r. If the velocity is less than the v, the satellite traces an elliptical path with the Earth as far focus of the ellipse. If the velocity is greater than v, the satellite also traces an elliptical path again with the Earth as near focus of the ellipse. A satellite which remains stationary with respect to a point on the Earth is called a geostationary satellite. The geostationary satellite is stationed at a height of about 36,000 kilometers above the equator. The condition for satellite to be geostationary are three conditions. The first condition, the satellite must orbit. The satellite orbit should be concentric and coplanar with the Earth's equator, which it moves with the greatest circumference to the Earth. So, second, the direction of rotation of the satellite around the Earth should be the same as the direction of rotation of the Earth. Third condition, the period of the geostationary satellite should be the same as the period of the Earth's rotation about its axis. Ladies and gentlemen, the total energy E of the satellite orbiting the Earth is given by E equal to negative GME M divided by 2R. And the escape speed of the Earth is defined as the minimum speed with which an object should be projected so that it can escape completely the gravitational pull of the Earth. And finally, escape speed from the Earth's surface should be v equal to square root of 2 square root GME over R. Ladies and gentlemen, that's all for today's lesson.